So, dear authors and invited guests, welcome to our technical session 2B. I am Riddhi Gohil, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Smart Trend in Computing and the Communication. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 8 presentation and also each presenter will be given 8 minutes for the presentation and the 2 minutes for the question answer. So on 7 minutes, I will raise a gentle reminder to conclude your presentation. So there is another request to all, please stay connected with us till the closing remark. If you have any query and update, please let me know in the chat box. So just before we get started, I would introduce to all our chair of the session, Sir Chitendra Bhatia. I welcome you to in this session, sir.
Thank you. Thank you.
Yes, sir. So, sorry. So I would like to start with our first paper. Our first presenter is Avita Sharma. Paper title is an analysis of smart kitchen gadgets and a smartphone application for the smart cooker. Yes. Present Kavita Sharma or not?
I think she's not there.
Yes, sir. Yes. So we can move our next presenter. So our next presenter is Ani Nandkishore Aher, and the paper title is Audio Compression Using Quantum Neural Networks.
Hello.
Hello.
I need to check regarding my presentation. This is paper
Yes,
number
sir.
61.
Yes, sir. Which version room you belong to?
This is I'm part of your section B. My paper is 161. Meta learned word embedding for few short sentimental analysis.
Yes, sir. Yes, sir. You are belong to this session.
So shall I proceed or?
No, sir. I will announce your name. Then you can proceed for the presentation.
Okay. Actually, I was facing some challenges to log into, but that's fine.
No problem. So when I think she is also absent. So we are moving forward our next presenter. Presenter is Costa, and the present title is a design of sensory Internet of Things for making sustainable agriculture ecosystem and experiment setup and elaboration.
I said nobody is presenting. Who is there?
Yes, sir. First, 3 or 4 presenter is not coming.
Okay. Let allow the next one so that.
Yes, sir.
Our
next one. Our next presenter is Edlen Ibenger P, and the paper title is Land Use and Land Cover Classification and the Changes Detection Using Machine Learning Approaches.
Yes, ma'am, I am present over here, ma'am.
Yes, ma'am, please.
Okay, I'll share my screen. Ma'am, is my screen visible?
Yes, ma'am. Yes.
Visible. Yes, please continue.
Okay. Good evening, everyone present here. I'm Adlan Ebenezer. I belong to Department of Computer Science and Engineering from SRM IST, Vadapalani campus, Chennai. And the topic for today's presentation is land use and land cover classification and changes detection using machine learning approaches. In the field of remote sensing, it allows everyone to learn about the physical characteristics of our Earth's surface without being actually over there. And it also gives a utilization to analyze and identify the various things that are present on our Earth's surface and also its properties, where it can be both natural and as well as the artificial. So with this, we'll be able to observe the behavior of the land use and land cover changes which are actually happening on the earth's surface. So these remote sensing images gives a incredible resource of spatial and temporal informations. So when we take about the spatial information, we have so many spatial features in and remote sensing images, and the temporal images is for every time to time we will be able to record the images through satellite. And likewise, when we come for the land cover, it refers to the surface that are actually covered on the ground. It can be a vegetation, water, or a bare soil. Likewise, when we go for the land use, it refers to how it has been used. So how the land cover are getting used for the purpose of social or economical activity. For example, if we take a vegetation area, whether it has been used for an agriculture purpose, or if we take a bare soil, it can be used for a constructive purpose, or it can be used for a recreation purpose. So likewise, these comes under the land use purposes. So to understand the various progress of a land changes, whether it is a past, present, or in future, how a land is getting changed for a specific area or a specific site, this land use and land cover modeling is required. So with this one, who are getting benefited is the resource management, the forestry department, and the government authorities has been benefited by knowing the changes that are occurring in a specific area, which in turn helps them to conserve the environment. So with this, we start with a survey. So in the first journal, they have taken the study area as a Nile Basin, which is in an Ethiopia. And the data set they have taken is Landsat 5, 7, and 8. And the pre-processing method they have followed is atmospheric and topographic correction. And the classification method they have followed is the maximum likelihood classification. And for prediction, they have taken land change modeler. And based upon these methodologies they have used, and they got the overall accuracy for the various years of 1990, 2005, and 2019. So these are the land cover changes are detected for each and every 15 years using the dataset Landsat 5, 7, and 8. And in the second paper, the study area, they have taken it from the Sikkim Himalayas, and the data set they have used is Landsat 5, and also they have taken the Sentinel 2A data set, and the pre-processing technique they have used is geometric correction, radiometric correction, and the classification they have used is KNN classification, and they have obtained an overall accuracy of 85.67. And in another paper, the study area is Hooghly River in India. For 2 different years, they have did the classification. One is for the 2001 and another one is for 2007. So for this also they have taken a Landsat images, and for the pre-processing they have taken atmospheric correction. Classification they did decision tree. For prediction they have taken SMARTCOM model, which is based on the stochastic learning. And the overall accuracy they have acquired for 2001 is 81%, and for 2007 is 89%. And for the fourth paper, they have taken a desert area, which is sub-Saharan Africa, for another 2 different years from 2004 to 2008. And again, the data set they have used is Landsat 8 and Sentinel-2. And the pre-processing technique they have followed is atmospheric correction. Classification they have used is a deep convolutional neural network. And for prediction, they have used a ARIMA model for 2 different years, 2018 and 2025. And the overall accuracy for classification, they have achieved around 90. And the overall accuracy for prediction, they have achieved for 91%. And at last, we have another study area, which is a forest area, Iranian forest area. They have used the Landsat images. And for methodologies, pre-processing, they have used geometric correction. Classification, they have used SVM model. And for prediction, they have used the ANN approach to based on MLP and MC model for the year 2024. So they have predicted for the year 2024 based upon 93, 2002, 2012, 2016. With these data, they have predicted for 2024 also, and they have achieved these overall accuracy for the respective years for that forest area. So with this, uh, uh, we have carried forward this work with image acquisition. So in this image acquisition, we have acquired the satellite images from LISS sensor. So this is actually we are acquiring from our Indian portal. We are referring it to a Bhuvan website where we'll be acquiring the satellite images of the various location. So this LISS stands for the linear self-scanning sensor. Through that sensor, it will be capturing the images of the various places, and we have taken it for the year 2009, 2012 and 2015. So for the period of three years interval, we have collected this data from Bhuvan portal. And after acquiring the image, we'll be carry forwarding with the pre-processing technique.
Sorry for the interruption, ma'am, but you have only 1 minute left to conclude your presentation.
Okay, ma'am. After pre-processing, we'll be going for the image classification, and we'll be doing accuracy assessment, and the changes deductions will be calculated. The study area which we have taken is a hilly area in a Tamil Nadu region, and these are the input data we have collected, and the format of this data will be in a GeoTIFF format. And this is how the extracted images will be there for a Bhuvan, from the Bhuvan website for the year 2009, 12 and 15. And for pre-processing, we are doing geometric correction. So geometric correction is nothing but we are correcting the coordinates so that when we do the classification, it will be very proper. And also we are doing the layer stacking where we have everything in band. So we have to stake it in every band wise so that the classification accuracy will be improved for that also. So for classification, we are using the random forest model. For training data, we are using the shapefile of the respective region. So this shapefile can be generated using this ArcGIS software, where the location, the shapefile of the location will be generated, and we can use it as a training data. So we are going to classify into two things. One is a forest area, and another one is a non-forest area. And after we proceed with the random forest, we have acquired these results for the these 3 years. The green shade represents the forest and the yellow one represents the non-forest. And for predictive analysis, we have used Markov chain model. So we have a dependent variable and independent variable. Dependent variable is the classified image, and the independent variable are the spatial variables, where we have a slope, aspect, hill shade, and the distance roadmap. So these are obtained from the DEM Catrostat 1 from the Bhuvan portal for the respective area. So with this predictive analysis, we'll be getting a change map from 2009 to 2012. What are the changes happened, and from the 2012 to 2015, what are the changes happened. After getting this changes map, this will be a dependent variable, and using the dependent and independent variable, we will be able to obtain the predicted LULC map. So for the year 2017, we have made a prediction, and this is how the changes will be occurring on that particular hilly area. And these are the results obtained for the various years. So we have calculated the user accuracy, producer accuracy, overall accuracy, and kappa value. So this kappa value is, since it is more close to 1, it is having some higher efficient value. And while concluding this one, so this random forest gives a high accuracy for the year 2009 as 93%, 1294, and for 2015, 95. The future scope of this method can be improved by including more of a spatio-temporal variable like distance from the forest edge, settlements, water bodies, social type, and the climatic data can be included, so that we can improve the prediction accuracy also in a in futuristic way. Thank you for giving me this presentation.
So, ma'am, what was the ratio of training and testing data set when you were with accuracy?
80:20, sir.
80:20. Did you try it for
Yes.
70:30 or another ratio? Just I'm asking.
Yes, sir. But when I tried for 70 and 30, I'm getting this accuracy little bit low. When I change the ratio to the 80 and 20, I'm getting a better accuracy, sir. Since I've tried for the various ratios, I'm getting a better value for this 80:20, sir.
Okay, so another one more question, that in your pre-processing, right?
Yes,
With the architecture
sir.
which you have shown in the pre-processing, 3 things you have mentioned, right? Geometry and 2 more things you presented. When you go back to
Yes,
that,
sir. Yes, sir.
yeah.
Yes,
So
sir.
atmospheric correction, layer stacking, and geometric correction. So all these 3 means you have tackled while doing
Yes, sir.
pre-processing.
Yes, sir. I have used. So first I'll be doing the layer stacking, because since it is in satellite image, we'll be having everything in band wise. So
Okay.
when we go for this Bhuvan website, we have 4 different bands that has to be staked very properly, so that we can obtain the information in proper order. And atmospheric correction is when we capture the image, we have this cloud covered area also. So to remove all those things, we are going for this atmospheric correction. And for geometrics, to arrange the coordinates correctly for the since we are using multi-temporal for that geometric distortion, to avoid that, we go for this geometric correction, sir.
Okay, thank you. Fine. Okay, please.
Thank
you.
Okay, thank you, ma'am.
Okay, ma'am, I'll stop my presentation.
So our next presenter is Kavita Sharma, and the paper title is.
We would like to have this Achal Kostas. We have put in a request. So if it could be kindly done first, we'll wrap it up in exactly 8 minutes.
Sorry, ma'am.
We're presenting from our side. So we'll take exactly 8 minutes. So we would like to have it first.
Paper number 171.
Paper number 171.
Yes, ma'am. There is a, after 3 presentation, Achal Costa will be presenting.
Okay.
Then it will be difficult. Can we have it up fast, so that even the session chair can ask, I mean, like, we would like to wrap it up faster.
Yeah, sure.
Yeah.
It's okay.
Can we start presenting?
Okay, ma'am, no problem.
Yeah. Achal, we can start it immediately.
Okay.
Yeah.
Okay. Thank you, everyone. Thank you, ma'am. Thank you, everyone. Good evening, everyone. My name is Anshul Costa, and I'm along with Dr. Chandrani, ma'am, and Sunil Khilari, sir. We are working on this paper presentation, so I would like to start my presentation. Okay. So there we are. Here we are using a drone with the Wi-Fi connectivity and the phone holder on the drone and sensors for the ground. As you can see in the image, we are using the drone technology for the agriculture and with the sensors to reduce the human effort and lots of safety features along with the lots of safety features. Here we are using some sensors like a Wi-Fi model to connect with internet to make it Internet of Things. Internet for the internet connectivity, we can use Wi-Fi model and GSM model too. And the microcontroller is will be here like Arduino and any type of controller like Atmega section we can use here to give the instruction to the Wi-Fi module along with some sensors, moisture, humidity sensor, temperature sensor, RF module, and mobile phone for the live video. Live video feature will be, it can be less, it can be less the cost price for the project also. Okay, if they want to use a live video streaming for this too, it will be almost automatic, but they can view the video also. Okay, as you can see in this image, this is the way how this project can be worked on the sense on the field. Like a yellow boxes you can see down here below. These yellow boxes are these boxes can be placed on the ground on the field. Each and every box have the connectivity with some wireless sensor, and some sensors they can get the information of the soil, humidity and temperature, like this kind of information. They can also have a camera and smart intelligence with the box. According to their calculation, they can send exact information to the drone when the drone will come over on the when the drone will come in the contact with these box accordingly. So the device number, according to the device number, we can find out the area on the particular area, what is the situation on the ground. This information can be sent to the cloud. As I'm going to show you a live demo here. I'm going to minimize it. There is some data. There is some data is being processed on the internet. I'm going to switch my video to the board.
Achal sir, slide is not movable.
The slides are not moving here. Achal.
Is it visible? My screen is visible to you?
Screen
On the
is
title
visible.
screen.
Ah,
Yeah,
now.
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 Okay, okay. I'm going to stop the share. Stop sharing. Once again, I'm connecting it with the switching it with the USB camera. So can you everyone? Can you see the video? The kit is over here.
Yes.
Okay. So this is the microcontroller we are using here. This controller is Atmega 16. This is the sensor getting the information. This sensor we can put on the ground, on the field, and the sensor can send the information using this transmitter module. The transmitter module can be put in the box on the ground, as you have seen on the ground, the yellow boxes over there. Here we will have a drone. Here we will have a drone, and the same drone will have the this kind of technology connected with the drone. Okay, so there will be a receiver. There will be a receiver like this. This will receive the information from the ground, from each device, and send it with the ground, send it to the ground. So here we are using a Wi-Fi module. This module here, we are using the Wi-Fi module. This module will send these information. It will process the information and send accordingly to the cloud. Now I'm going to share this screen. I want to show you some data which is presenting on the ground, on the internet platform. I hope it is visible to you. This is the IoT chart. This live data is being inserted on the graph. According to the graph, we can take the decision, what is the situation, what is the current situation, and what was the previous situation was on the ground. So that was the technology can be used with the drone. Thank you. Thank you, ma'am.
Okay, thank you. Thank you, Achal Costa.
Thank you.
So any question from the audience side?
Yeah. Hi, Anchal.
Yes, ma'am. Hi.
Am I audible?
Yes,
Yeah.
ma'am.
So your title is sustainability. So I just wanted to ask you if you are focusing on social and economic aspect of the agriculture.
Social and economic aspect. Okay. Ma'am, could you please elaborate?
She is wanting to understand, Achal, she is talking about whether we are considering the pricing aspect, because we have mentioned a sustainable agricultural ecosystem. So whether this is going on to, I mean, whether the entire experiment which we have performed, whether it is going to each and every, farmer, whether he has or he doesn't have capability, and whether that model can be replicated further by them, and also the price perspective with respect to the research which we have conducted.
Can I explain it in Hindi, ma'am? Without permission?
Yeah, sure.
Okay,
Sure.
thank you. मैम इसमें क्या है, जो भी टेक्नोलॉजीज होती हैं हम अपनी फ्लेक्सिबिलिटी के अकॉर्डिंग, जैसे कि हमारे कॉस्ट इफेक्टिव होना चाहिए, इसमें हमने एक मोबाइल फोन के लिए एक होल्डर यूज किया हुआ है. इससे क्या होता है, वीडियो के थ्रू काफी कुछ फार्मर्स जो होते हैं वो वीडियो के थ्रू ज्यादा कंफर्टेबल होते हैं, एग्जैक्ट वहां की सिचुएशन देख के वो सेटिस्फेक्शन भी होता है. और रही बात इसकी, जो सेंसर्स हमने ग्राउंड पे प्लेसमेंट किया था सेंसर्स का, वो अपने अकॉर्डिंग उसको मैनिपुलेट भी कर सकते हैं. इसमें हमने जो वायरलेस रिसीवर यूज किया था, रिसीवर एंड ट्रांसमीटर टेक्नोलॉजी जो यूज की थी, वो एक एरिया को कवर करती है. तो किसान को पता होता है कि किस प्लेस पे कौन सी किस प्लेस को मॉनिटर करना उनके लिए ज्यादा बेनिफिट रहेगा. तो इसको ऐसे अपनी टोटल कॉस्ट के अकॉर्डिंग वो इसको एक्सटेंड भी कर सकते हैं और इसको अपने बजट में भी लेकर रख सकते हैं. मतलब जितना ज्यादा इसमें हम इन्वेस्ट करेंगे, जितनी टेक्नोलॉजी वो फीचर्स जितना वो डिमांड करेंगे, उसके अकॉर्डिंग इसकी कॉस्ट वेरी हो सकती है.
Thank you so much. So I understand that this is basically for the increasing productivity, I guess, if I'm not wrong, ma'am.
It is for currently it is for increasing the production and also in a cost effective manner. So increasing the production will and in a cost effective manner and reaching out to a number of farmers based on their affordability, we are ensuring sustainability.
Okay.
Hence,
Sure, ma'am. Sure, ma'am. Very nice and innovative idea. Congratulations
thank
to
you.
both of you.
Thank you.
Very innovative.
Yeah. Thank you. So we leave the, we are done with the presentation. Thank you, Anchal, for being the co-author, and we have happily worked out with you. Thank you.
Thank you.
Okay, that's fine.
Thank you. Thank you.
Already asked.
Okay, sir.
Okay, fine.
So our next presenter is Kavita Sharma, and the paper title is Analysis of Smart Kitchen Gadgets and Smartphone Application for the Smart Cooker.
Hello, am I audible?
Yes, ma'am.
Okay. Can I share my screen?
Yes, please.
Okay. Is my screen visible?
Yes, yes, ma'am.
Okay,
Yes, yes.
okay. Thank you.
Fine.
Thank you for thank you for confirmation. Respected panel members and all. Good evening. Myself, Kavita Sharma, research scholar in IGDTW Delhi, working under the guidance of Dr. SRN Reddy, working as a professor in the university. I am working on this project with my team, BTech students. So I am presenting here the paper and analysis of smart kitchen gadgets and a smartphone application for the smart cooker. The content of the application: introduction, problem faced in the study, objective of the study, existing solutions, user survey, and their report, findings, proposed mobile application, and their working methodology, result and discussion, challenges, conclusion, and references. Basically, we all know that IoT is increasing day by day, and it is entering in each and every field, like healthcare, agriculture, communication. In the same way, it is also entering in the smart homes. In the smart homes, we have a smart kitchen, and there are and there we are expecting many gadgets which are working smartly, basically electrical gadgets, and they are also IoT enabled. So that's why today in this busy schedule, many women's, man's, and students are busy outside from their homes, and children's and students, children's and elder peoples, or we can say unhealthy people, stay back. So for them, there is cooking is a big challenge for them. In the societies, and everyone want to care, and they want healthy food. So, but they to spend much time in the kitchen is a challenging task for the people in today's society. That's why we have raised problem in the paper to sort out so that they can have healthy food in minimum time. There was the objective of this particular research is to design and develop an mobile application, and smart automated cooker was designed in a simulated environment, but there was not application developed for the same. So here to have the remote access of that particular smart cooker, the objective was to have a mobile application so that can be accessed remotely. For that, we have a literature survey, and we also have a user survey, so that we can understand the requirement of the society and what the society needs, or what the people, what type of smart gadget they want for their smart kitchens. For that, we have studied the different technologies used in smart food processor, Philips coffee machine, dishwasher, microwaves, instant food, ambient temperature control, smart mug, automatic sensor, trash can, Anova culinary sand, void precision cooker, and air fryer, and other or related. These are the market products, and other literature survey was done. And this is the question. Basically, after doing this literature survey, we find that there are some gap, or there is not the devices which are up to the mark as per the today's IoT technology, or today's technology. They are not up to the mark. For to have the users need also, we design a questionnaire for the product. There are 34 questions. Some questions are yes no questions, means the user have to give information as yes or no, they want or they don't want. And we have in that we have got 50 responses. In that 50 responses, we have working women, mans, elder peoples, and students also. In yes no answers, we can find here that in question number 13, these are the 5, 8, 9, these are the question numbers, and question number 13 shows that the society need a smart cooker which is enabled, which is technology enabled. And in question number 16 also we have got uh, yes responses, extremely high responses, positive responses, which shows that it is the market demand or society demand to have such type of device. And in the same manner, 26, 27, 28 questions also have the positive responses, which shows that remote handling and audio enabled device is the requirement of the society. The next thing is the quality parameters or other pricing, just like as quality, what type of quality they need, better quality or low quality will also be there, will be supported by the society. So we decide these 6 parameters: quality, innovative, value, pricing, functionality, visual appearance, and safety. So here also in quality also matters, and value addition, pricing, visual appearance and safety are have extremely importance for the peoples. Taken as a sample uh, in the user survey. So from the literature and from user survey, we find different gaps, and ultimately we conclude that the smart automated cooker is a requirement of the society, and mobile application is also required to handle that particular smart cooker remotely. So to command cooker, yes sir, hello. Hello.
Yes, sir. Yes, ma'am. You have only 1 minute left for the presentation.
Okay. No problem. I will conclude within 1 minute. So in that particular proposed model, we have different containers. That is the hardware components. There are various containers, washer and cooker that was already designed in the simulated environment, and now it is going to be designed in the real environment. And this is the block diagram of the proposed model. Here, this is the smart cooker, which have these 3 parts: containers with ingredients, washer, cooker, and this is the user. And there is a mobile which will have the mobile application. This is now targeted in this particular study. So in this mobile application, user authentication, role based user authentication will be there, and there will be device control instructions. Means remotely you can instruct the cooker for cooking, and as the user will give the time as per the set time, cooking will start. And there will be cloud storage for analytics, and local storage will also be there, and synchronization between the local storage and cloud storage will also is also there in the mobile application. So database update information, if there will be any update in the mobile application for any recipe by the user at any time, and before starting the cooking, then it will be accordingly updated in the local database also to start the cooking. This is the working methodology. It shows the complete working, how that mobile application will work. Basically, it is divided into 3 stages. In the first stage, it will send the instruction whether all ingredients or water supply in all the containers are associated with the product or with the device. After that, after a complete successful checking of all the containers, then ingredients will be shifted from one part to another, and after ultimately they will go in for the cooking part, and there they will be cooked. After that, it will be and time to time instructions will update in user will be updated with the current state of the device. With the help of that particular application, all these facilities will be provided in the mobile application. And after cooking, user will rate, and in future the mobile application will recommend as per the user ratings. So this is the descriptions of that. After that, basically here, after literature survey and user reports, this particular mobile application is designed, and we also find that it is the need of the society, and this particular product is innovative and fulfill the requirement of the society, and will ease the cooking, and will also help people who have a challenging factor to spend time in the kitchen.
So, madam, finally, I
here,
want to ask you that
yes, sir.
which sensors, which are the sensors you used in your this designing your this
Sir,
framework?
basically, in this design, we have used the Raspberry Pi as the development board, and after that, we have used different motors, just like as the we can say stepper motor. For that will be embedded in the containers, and one will be the solenoid valve that will be for the water container. Sorry, and we also have weight sensor to weight and to customize the mm, ingredients or other required material. And we have taken this concept from the coffee machine. We have the coffee machine. For 1 cup there is a particular measurement, so in the same pack we have other ingredients, just like as the we can say salt or turmeric, etc. So for on the same pack we have used the DC motor for that. So this type of
So, is
things.
there any prototype existing? Ma'am, is there any existing prototype similar like work you miss or the work which you extended?
Sir, this prototype is not already existing.
So why
Basically,
you not
different.
gone for the patenting? If this is not, then you may go for patenting instead of publishing the paper.
Sir, that is already patented. This is patented, and the application is sent in 2020, and the patent is published for the same, for the design of this particular product.
Granted now?
Sir, it in the process of granting. Basically, it was published in 2022.
Okay.
And now mobile application is almost on the completion. After that, some hardware prototype will be developed. That after that we will proceed for the granting.
Okay, fine, good.
Yes,
Thank you.
yes,
So,
sir. Thank you, sir.
you
Thank
can-
you, sir.
Okay, so next,
Okay,
please.
okay, sir. Okay, thank you, sir. Thanks a lot for.
Yeah, thank you so much. So next presenter is Rani Nandakishore Aher, and the paper title is Audio Compression Using Quantum Neural Networks.
Thank you, ma'am. Can you confirm if you are able to see my screen?
Yeah, make it full screen. Fine, that's fine.
Sure. Hello all. Good evening.
Fine,
Thank you everyone for giving me this opportunity. My paper ID is 123. The topic is audio compression using quantum neural network. I have my co-presenter also, Nandakishore Aher, along with me. This is the agenda I'm trying to cover for today, which is having introduction, relevance of proposed work, architecture, methodology, and conclusion. So currently I'm working on one of the healthcare domain project where client wants to move their on-premise data center into cloud as a part of their modernization journey. We are implementing one of the data warehouse with help of Snowflake. And when I studied this particular product, I understand the data stored in Snowflake is in compressed form, and it while retrieving also it decompress. So that was the motivation where I started understanding more on the data compression aspects. Further, I try to understand the market trend for data compression, and currently like 7.7% compound annual growth is projected till 2030 by one of the global research market. When there is a data processing involved, we required lot of computation. And that is the reason quantum computing is heavily considered in this space. Currently, quantum is in its infancy state, but still there is lot of research is happening in the quantum area. I've listed some of the use cases here in telecom domain, where audio data is generated and they need to store this data. So they have challenges around the storage of this particular data. In quantum, in call analytics also, they require a lot of there is a need of audio compression as well. And we can see that in the next slide, this particular volume growth, we are expecting like 181 petabyte of data into until 2025. So we can see that Netflix, YouTube, they require high quality of amount of audio data is required, and storage is one of the challenge. So that is one of the important aspect we are going to touch upon with this framework. I've listed here compression pros and cons, like we can achieve storage optimization, we can reduce the data transmission time, and we can have cost saving, and we can do efficient data exploration with help of audio compression. There are certain drawbacks also. We required lot of heavy computing resources to perform these compressions. In September 2021, I have conducted one of the survey. So this is the stage where I completed one of the, this research is having literature survey and user survey also taken into acceptance. So this survey was conducted in September 2021, where all the industry people contributed. There were 110 responses, and we can see that data stored and data compression technique, these are having a very good weightage also, and that is the reason this is the focus area. So we have developed one of the framework for this audio compression, and the basic principle of this one is sound reduction is to remove the signal redundancy, while the original message should be intact. We develop a novel framework for encoding and compressing the audio signals in their FRQF formats. So this method simply uses 3 qubits and store the amplitude information in the audio signals, which enables its usage in the standard quantum machine learning. So we have developed this particular architecture which has encoder and decoder, which is used for like compressing and decompressing the audio signals basically. So we can see that there are certain convolution layers and max pooling layers are also introduced in this. And based on this one, like we are trying to achieve the compression. So in this piece, basically, when the waveform information is there, we try to convert it into the digital format, which is like stores. There is one of the quantum representation of digital audio, which stores the audio amplitude and time data using the entangled quantum bit sequence as a quantum representation. In this particular, there are 2 phases of procedures has been used. And first one is like converting the initial state, like amplitude data is initialized to 0 bracket. And then there is a value setting procedure which produce amplitude data for every trial. It initializes the phase using unitary transformation for the FRQS state. So you can see that this is the FRQS signal is the input signal basically. So that is what we try to achieve with this particular framework. So what are the methodologies and tools techniques we have used is like we used Python runtime, TensorFlow library and quantum tensor library here. And we use like 70% of data and 30% of test data with 20% testing and 10% validation. And we try to achieve this compression factors, basically some of the parameters, compression factor, peak signal ratio, and normalize root square error. So based on this particular framework, our conclusion is that we can minimize the compression errors if we are using quantum machine learning algorithms, and we can also obtain the we have seen we obtain the saves or we have obtained the savings for the space in the database also. So in future, we can study more different techniques on the quantum coding algorithms, and we can increase the audio file compression ratio also. These are the references which I have referred. That's it. Thank you.
So you have referred 1948 paper also.
It's 31 paper.
Very first paper.
Yes,
Shannon.
yes.
So it was for Shannon, 1948.
Yes.
So my question is whatever the approach you have proposed by quantum computing, can you tell me how much by how much factor your audio file is compressed if I compare to your approach with traditional approach?
Yeah, so here we consider like 70% of the training data and 30% of the test data. And for some of the examples, we have seen that so far we have achieved 50% of the saving space. And I mean, there is a still scope to further understand if we can increase these convolution layers, and we can further improve that particular compression also. Because currently,
have you done the literature review of their existing techniques? Which are, can you tell me which are the standard compressed audio algorithms, audio compression algorithms? Which are that? Any, if you explore? Because when we compare our, means when we show our results, so it is necessary to show or compare it with some traditional approaches also. So there are so many audio compressions algorithm, existing algorithms are there. So this is my suggestion, that please extend your work by
Yes,
comparing it
sir.
with traditional algorithms.
Sorry to interrupt. Nandakishore this side. Yeah, we studied that. Like there are some JPG compression techniques, and all these are there in the literatures. And what we are trying to achieve, instead of using these codecs and JPG kind of algorithms which are already there, how using the quantum and the hybrid of not only quantum, the hybrid concept of deep learning using autoencoder generative models and the quantum circuits, can we achieve more compression, not only compression, but how effectively we compress it? Because the literature reviews, what is the limitations right now is they're taking quite a lot of computations to compress the data, because the deep learning or CNN requires the GPU's kind of infrastructure, and the computation is very high. Yeah, so how the quantum can help there? That is the one of the gaps which found, and we are working on that particular gap. That is the one thing. And another thing, there are different types of data, like whether it is a audio data, whether we can do the compression on a image data, how we can do for the lossy compression, how we can do for lossless compression. So all the aspects are we are studying it and we are researching it. But this paper which we have produced is for only focusing on the audio part of it. Using Librosa library, we have converted wave file into the into our zeros and ones for the algorithm to compress it using minimum qubits. Basically, here what we are achieved is using only 3 qubits. We have compressed that file. Okay, but now again the next part is how we can decompress it, and we will see whether what is the original audio is there. Are we retrieving it the same quality of the
same quality that is needed, highly needed to check. Yeah. Okay, fine, sir. Thank you.
Yeah, thanks.
Sure. Thank you.
Thank you. Sorry.
Yeah, thank you.
Let us have next presentation, please.
Yes, ma'am. So next presentation is Karthik Kishore. And the paper title is Inflation Targeting Monetary Policy, the Way Forward.
I would request one thing here. Jiten sir, do we have, can I know when the time of paper number 161 will come?
I think Riddhi can be a right person to tell you about this.
Sir, yes, sir. Sir, after this presentation, your presentation will become.
Okay, thank you, Riddhi. Sorry.
Yeah.
Good evening, everyone. Am I audible?
Yeah, Karthik, audible. Please continue.
Okay, thank you. I hope the screen is visible.
Yes.
Okay, so our topic for this paper was inflation targeting, and we analyzed the monetary policy. Basically, as the budget is approaching in just next week, the nation's economy is an interplay of three major policies: the fiscal policy, which comprises of the basically is hand of the government, monetary policy, which is in the hand of the institution. Usually the central bank acts as the regulator, and the trade policy, which talks about export and import promotion. For this paper, we have focused mainly on monetary policy and its analysis. The Before we come to the objectives, very briefly, let me tell you about the monetary policy and a major reform that happened in 2016. Urjit Patel Committee was set up under then Governor of RBI, who was Mr. Raghuram Rajan, to reform the monetary policy committee to reform the monetary policy mechanism in which the repo rate was set, and with a strict target on inflation, the reforms took place before 2016. Mainly, the committee comprised the decisions were taken by the RBI governor, which was on the advice of technical advisory committee. But now it was a member of seven from different expert groups, and it also government also had a share in it. Coming to the objectives of this paper, the first objective is to find out, after the 2016 reform, to what extent repo rate have been an effective instrument in containing inflation, because the reform took place to control the inflation. Secondly, whether the inflation forecasted by the Monetary Policy Committee has found convergence with actual inflation. Before every quarter that MPC sets, there is a prediction which MPC highlights in their report. So how far it has been correct. The third is effectiveness of the repo rate during the COVID period. And the final one is to what extent the Taylor rule can be used as a template for deciding realistic repo rates. As a broad framework, how far we can use the Taylor rule. Coming on to the first objective, repo rates and the inflation containment, and not as, if we see 2016 as a boundary, before 2016 you can see the huge divergence. While the repo rates are declining, in spite of that, the CPI, which is the inflation, consumer price index, as inflation for the consumers, is quite rising. Again, further in 2010, when the inflation went a further around 12%, the increased repo rate was marginal. On the contrary, it would be seen that the repo rate during 2014 to 16 was in consonance with the inflation. However, after intervention, when the repo rate was brought down to 6, inflation came down from 4.9 to 3.5%. So repo rate did became a potent weapon with a focus shifting to CPI. Earlier, it was on wholesale price index. The second objective was to identify how far is the correctness of the prediction by the MPC of the inflation. Before we understand this, let's see this figure. This, I think here it's more clear. When we see this figure, we can see that the predictions and the reality has mostly been not in consonance with each other, although there have been phases when the predictions were according to the actual inflation rates, but mostly they have faltered. The period from June 2016 to February 2018 is particularly interesting, as the MPC predicted an increase in the inflation, whereas the inflation rate in these 10 months had actually fallen. It is quite likely that the MPC member failed to comprehend the underlying inflation dynamics in the wake of fiscal policy. During August 2018, MPC predicted inflation of 4.8%, whereas the reality is actually decelerated. There are three major inputs to inflation forecasts, namely food, fuel, and core inflation. Whereas food and fuel inflation are supply driven, core inflation is demand driven. With the benefit of hindsight, it can be said that the MPC failed to forecast sharp deflationary trend in the food inflation during 2018-19 and predicted instead an increase in food inflation. It also failed to anticipate the impact of demonetization, which affected the informal sector and the farming community very adversely, and didn't see demonetization as a major disruptor as far as inflation was concerned. So when we see this, even though the reform took place, the actual impact has been a bit limited when we talk about the correctness of the inflation forecast. Moving on to the third parameter, which is effectiveness of repo rate during the COVID. The healthy there has been a healthy correlation between the repo rate, CPI, and GDP during 2017 to 19. Inflation was always around the minimum of the glide path, and the GDP was around 7%, till it climbed down to 3.7 in August 2018. The defining moment has been the pandemic year of 2019 when the to 21 when the MPC has maintained a low repo rate of 4%. Given the fact that GDP had plummeted to -7% in January and -8% in June 2020, the RBI didn't want to aggravate the supply shocks confronted by the economy due to severe constraints in the movement, particularly in the sectors like transportation, services, and manufacturing. The RBI also contemplated fiscal policy when the finance minister announced a slew of fiscal packages in March 2019 to resuscitate the informal economy. There was a fine synergy between the monetary and the fiscal policy in the sense that the fiscal incentives were promulgated through suitable policy instruments by the RBI. The revival of the economy after 2022 is a testimony to the foresight of both the RBI and the government. So, what basically the data suggests is that while this huge fall, sharp fall in the COVID that we see in the repo rate and the repo rate along with the CPI has more or less have been in consonance even during the pandemic years, and that's a very good news. The other positive takeaway has been the consonance in the fiscal and the monetary policy, which are the two driving forces of controlling the money supply in the market and the inflation. Finally, when we talk about the Taylor rule as a template for policy determination, in John B. Taylor gave a broad framework to analyze or to determine the nominal interest rate that should be there in presence depending on several factors. These factors were the ideal interest rate, the actual inflation and the desirable inflation, which is here, and the actual and the desirable GDP. This rule has been applied by Alan Greenspan, who was the governor of Federal Reserve Bank from 1987 to 2006, the longest serving Federal Reserve governor, and he has been successful in reducing the inflation in US in the worst of the times. This formula, although formally has proven its mantle, however, when we talk about the usage by the usage in Indian context, has more or less been limited, and the factors of politics or some other social factors seem to dominate over the real inflation rate. When we put the inflation numbers here and the desirable GDP growth here and the ideal rate to be 3%, we find that while the inflation rate or the repo rate in India should have been much higher, it is usually pulled down by the government, yeah, to favor the corporate in some of the cases, which in turn leads to higher inflation and is a negative factor on the pocket of the middle class. Overall, on the conclusion, we can say that it can thus be seen that the foresight that the transformation of India's monetary policy, which was governed by RBI governor to MPC, has adopted a better repo rate, which displays a healthy correlation between the short-term repo rate and the low inflation. There is also a healthy equivalence between the low inflation, high GDP growth, and reasonable repo rate from 14 to 19. Decision making by multiple members with diverse background, banker, economists, is a trend in the right direction compared to the earlier times before 2016. Thank you.
Okay, Karthik, fine. So, how many study of how many this economics papers you have referred for doing this your entire?
So we have taken out for the study, we have taken out the data from RBI paper, and we have referred a paper from Alan Greenspan, which was also mentioned. The formula which was used has also been referred in quite depth, and we have mainly referred to the theoretical papers from economists. And for your kind reference, that these are the 10 major papers which have been done.
This is your effort for your entire studies.
Yes.
Okay. Fine, Karthik, fine. Thank you. Thank you.
Okay. Thank you.
Thank you. Next presenter. Next presenter is Sumit Pandey, and the paper title is a meta-learned word embedding for the few short sentiment classification.
Is that my screen visible to all of you?
Yes.
Yes. Make it full screen. Okay, fine.
Okay. So, respected chair and my fellow members here, I'm Sumit Pandey, and probably I'm working on. I'm a student in computer science doing my PhD. So far, I have published 3 papers in Springer, and probably my approach and my thinking or my work is probably into mental health using AI and AI techniques. So here, during this approach, I have worked out on a meta-learned word embedding for a few short sentiment classification. This is my title, and I'll be talking about it, what I've done, and probably what are the things that meta-learned word embedding process endorse upon, and what is few shot. So probably my study will contain a few important aspects, including abstract introduction, some data representations, data explorations, because we make a very clear-cut conclusion based on the data sets which people have used in their researches and what experimentally we have brought as a difference over there by using some techniques, including model, experiment, and results. So just to brief you on this, meta-learned word embedding is a method for training word embeddings, which is representation of word vectors. So here, whenever I'll say word embeddings, I'll be referring to word vectors for sentiment classification task. It is designed for few shot learning. When we are saying few shot, because the model is trained on a very small number of examples and then applied to new unseen examples, which is predictive approach that we followed in that. The method uses a meta-learning approach where the model learns to learn quickly and adapt to new tasks with minimal data set along with predictions. In simple words, it is a way to train a model to understand the sentiment of a given text, even if it has only seen a few examples of that text before. Now, meta-learned word embedding for few short sentiment classification is important because it allows a model to quickly and accurately classify the sentiments of new unseen text. So this I want to highlight once again, that in few short sentiment classification technique, what you need is a very small data sets, because they have the ability to quickly and accurately classify the sentiment of new unseen text with a small amount of training data. This is very useful in real world applications where it is not always feasible to have a large amount of label training data. By using meta-learning approach, the model can learn how to learn quickly and adapt a new task with minimal data, which allow it to be applied with wide range of text classification tasks with a high accuracy. Additionally, in natural language processing, which is NLP or ANLP, it is very important to understand the sentiment of a text as it can be used in various applications such as recommendation engines, customer services, and opinion mining. So this is, we can see lots of applications where you find lots of recommendation engines which are totally based on certain type of behavioral activities that you perform, or your patterns. They learn your patterns and they execute. For example, if you go to any real world applications, maybe any e-sites or maybe e-shops, you'll find that their recommendation engine totally works on the kind of commodities, products, linings that you use, and based on that pattern and predictive approach, they offer you next kind of products, categories, and offerings. So this meta learning is playing a very important role, because now with few short sentiments, you can do a predictive analysis, and with a very small data set, you can train and you can get a better accuracy. So here the data set description which I'm talking about is, we have taken certain reviews from Amazon where 25 different product categories we have identified, and probably each product category is treated as a separate for a training or testing approach that we follow. The author uses a star rating of 5 to classify each review sample having a favorable or negative sentiment. So what we have done is, there are 3 categories that we have built into T5, T4, T2. A review that has received 5 stars is marked positive +1. A review is considered favorable +1 if it has 4 or more stars. A review is considered favorable +1 if it has 2 or more stars. Now, here the data set which is being explored, we are trying to point out close to 138,397 unique terms in the lexicon, vector bag of words that we are using in terms of that embedding, and 30,055 negative labels and 108,317 positive labels, where it comes to be distribution of reviews showing a major imbalance in distribution of opinions. Mobile devices, software domains can be utilized to analyze the system performance for a few short learning due to balanced nature. Now, in this MAML model, which is meta learning model, in this process of using sparse data to train a model to generalize new tasks, the goal of MAML is to improvise K-short, or we call it few short learning. During meta learning, the model is trained using the data from randomly chosen task or a batch of tasks. So here, if I talk about the batch of tasks that I've used and the random iterations which I've taken, it is from 10 to 10,000. And while writing this code, it has been observed that when the results are coming very closed in terms of not creating a delta, this loop will get exit. So I'll show that results. The meta learn word embedding for the few short classification task MAML needs to be expanded to learning rates, and they are used in parameters for MAML algorithm. So what I've done is, here we have followed 2 techniques. One is, what we have done is, we have done meta learned approach simply without a BERT model, and then we have done with a BERT model. And what we have observed that during this embedding, either it is segment BERT or tokenizing of a result sequence, we found that in BERT approach, the accuracy was very, very higher as compared to any singular model. So either it is a LAM model or a DLAM model, whenever any meta-learned approach is being combined with BERT model, it results better. So BERT creates a deep pre-trained bidirectional representation using a novel pre-training aim called as MLM, which is masked language model. BERT selects a subset of input tokens and random to mask. 80% of the tokens are replaced with masked token and 10% with the random word, and 10% are taken unaltered. In masked language model, facilitates the learning of distributed contextual representation due to encoder lack and prior knowledge about which the words encoder must anticipate. BERT creates 3 embedding for each token as illustrated in figure 1. If you look to the experiment, it has been employed 50 dimension randomly initialized word embeddings, 100 dimensions LSTM cells, and in a batch of 8 to 10 jobs every time from 0.1 to 10,000. And the maximum review length of 100 words for a MML model, the author has employed batches of 10 jobs, 0.1 to maybe 1,000, 0.001, a limit of 512 words for reviews and 786 dimensional BERT embedding in LSTM cells and BERT MAML model. The metric-based method that uses dynamic routing to learn class-wise representation. With BERT MAML, the data accuracy was close to 99.61. So here we have used Google Colab. Probably the code was in Python, and in that sequence of iterative approach of 10 to 10,000 iterations that were being done, we find out that in 50th cycle, in 40th cycle, the observation was that the loop was with a minimal delta, and it is getting out of that particular loop. Next important thing is the result that Oracle scores best of T2 schemes, which is 88.98%, because in one of the paper that we have reviewed, they've used this approach where the observation without BERT or with few short sentiment analysis, their results was 88.98%. And the worst of T5 scheme, when they tested on each scheme, it was close to 60%. BERT uses a complex multi-stage network with multi-layer embedding structure and deep self-attention through transformer, in contrast to any MAML unique or separated model, which uses a basic Bell STM model. The use of training and testing minimum sets or mini sets within a single cycle is the key discovery that enables us to monitor and maximize generalized performance. BERT embedding to initialize a MML model significantly improved our performance more than or less than 6% every time. So during this work, we identified three very important parameters, which I want to talk about. That meta-learned word embedding is a method of training word embeddings, which is a representation of word vectors for sentiment classification task. It is designed for a few shot learning, where the model is for few short small number of examples and applied to a new unseen example. This method uses a meta-learning approach where the model learns to learn quickly and adapt a new task with a minimal data set and using a hybrid optimized environment. In simple words, it is a way to train a model to understand the sentiment of a given text, even if it has seen few examples or text before, even if it has not seen any such examples or text before. Here, if you look to the methodology, you'll find that few shot sentiment classification, here the training of the model becomes very easy when you apply a BERT technique or LSTM technique. The reason is because here the two parameters get involved. Number one, your MLM approach, and parallelly or maybe a MAML model, and in combination with any other standalone model, maybe a BERT, where there are different layered structure which it creates, it brings out a larger accuracy, leading to the better results in terms of identifying sentiment approach. To perform any of these meta-learning, this model is trained. We have trained this model on the base set of tasks. Maybe this can be used for any kind of data set. Maybe, for example, in predictions, in real-time analysis, in recommendations, these approaches of sentiment analysis of any data set that comes can be trained and can be used. So in conclusion, what I can say is, due to limitations of DNN and NLP, the author decided to use meta-learned word embedding for few shot sentiment classification. The result shows that when embedding of the same size of a BERT initialization are used, the MAML with random initialization model would perform similarly to the MAML with BERT model. MAML and BERT use 50-dimensional vectors like BERT jobs, which use close to 768 dimension vectors, which can further be enhanced, because in the latest writing which we are doing, we are bringing this to 1068 because we are using backword size to be 512 words. The suggested model has achieved significant improvements in the public benchmark datasets, which are evident by experimental results. So in future also, if we want to analyze these sentiments, because as of now, any model which is getting trained datasets, they need to be very hefty and heavy. But with this few shot analysis, we have observed that with predictive approach and parallelly with trained model approach of by using it with some MAML and with some other model, maybe LSTM, maybe BERT, your results are much better as compared to the generic models or evolutionary model which exist right now. So these are the 10 odd papers where we have identified certain predictive approaches of meta learning and the use of artificial intelligence, and probably this result that we have identified was much better, close to 18%, 17% better in terms of the last results that have been identified in few shots analysis. So I believe in coming period of time when a realistic, quick, sentimental predictive approach has to be used, meta learning approach will help a lot in conjugation with any of the models which exist in terms of predictive approach.
So,
thank you, everyone.
Yeah. So, is there any another model apart from BERT model for MAML, so which performs the best in any case, in any circumstances?
Yeah. So, sir, we have studied one more model of recurrent and generative approach, that was LSTM model, where the challenge was that there was no prediction. So right now in this model, we have predictive approach, but in LSTM, in recursive or in generative approach, it was not happening. So we have compared 2-3 model. One was LSTM, other was BERT with recursive and generative approaches. So BERT was the better in terms of result as an outcome.
Second thing, you must include that in the literature review also, and you can refer the papers. See, you have referred up to 19, but some people might have done the good work. You can pick up any journal means related to your domain. You might get some more. Definitely, you have done so much experimentation. That is very nice. You can extend this paper for the journal also.
Yeah.
So my suggestion, you must include some 2021 to 22 papers and also confined to a specific journal which is related to your domain. So you will get the state of the art.
Correct. The suggestion is really good and implementable. Actually, we used some more papers. The latest paper was on a BERT approach only, but in this list I have not included. But if you refer to my complete paper, there are 21 papers that we have worked upon. But yes, we'll take this point.
Okay, fine. Good. Nice. Thank you.
Thank you, Jitenji. Thank you.
So the next presenter is Harsh Goyal, and the paper title is Stack LSTM Model for the Shakespeare Style Poem Generation.
Hi, can you hear me?
Yes, sir.
Yes.
Second, I'll be sharing my screen.
Arch, my request is that you focus on your core work.
Okay. I'll need to rejoin. I'm not able to share screen. Just give me a second.
Okay, fine.
Can you see my screen?
Yes.
Yes.
Yeah. Hi, good morning, good evening, everyone. I'm Harsh Goyal, and my co-presenter Sujit K is also here. And today I'm going to be presenting my paper titled Stacked LSTM Model for Shakespeare-Style Poem Generation. So as far as introduction is concerned, so natural language processing consists of 2 subsections: natural language understanding and natural language generation. So in this paper, we have used text generation, which is in the field of natural language generation. And text generation has a diverse set of practical applications, which include image captioning, text summarization, and question answering. And an interesting problem in text generation is the machine's ability to synthesize poetry from a collection of poems written by a particular poet. So in this paper, we propose a stacked character level LSTM model to generate Shakespeare-style sonnets given a corpus of his sonnets. So now as far as the scope of this paper is concerned, first I would like to say what are sonnets. So sonnets are basically 14-line poems broken into 3 verses of 4 lines each with an AB rhyming scheme, followed by a rhyming couplet at the end. So Shakespeare wrote 154 sonnets, and all his sonnets were of exactly the same style. And as everyone knows, Shakespeare's sonnets are widely recognized as the gold standard of poetry and language. And his works are primarily comedies and histories and were based on real events of his time. That was like 1 century ago. So the public was very influenced by his work and saw the world through his literature. And what we aim to achieve is that by recreating his literature based on seed faces provided on modern topics, people of this age will be able to relate to his literature better. So that's why we aim to generate sonnets that are similar to the style of Shakespeare, but at the same time aren't identical copies of his work. Now going ahead with the background work. So for this paper, we have referenced around 20 papers, and this is just a summary of the entire literature survey we have carried out. So poem generation is a very complex task, and initially a lot of poem generation was carried out using formal methods such as genetic algorithms, SML, etc. Over time, that is mainly in the last 4-5 years, deep learning approaches have become using RNNs were introduced, and these helped in understanding the context of the poem better as they contain a memory component. However, while RNNs helped in the case of generating prose, which is stories, they were not really good in generating poems because of the problem of vanishing and exploding gradients. So as everyone knows, RNNs become very slow and tedious in the case of long sequences. And due to the vanishing gradient problems, the models did not organically capture the rhyming scheme or the rhythmic patterns of poems, which is very important. So moving ahead, there have now been works on LSTMs, which are where LSTMs in a way can solve the problems RNNs face because they have gates and they can retain and forget information as and when needed. So that is the reason they can capture the rhyming scheme of the poet. However, in the particular case of Shakespeare-style sonnet generation, there has been very little work using LSTM, and this is the gap that we have identified. Also, the reason I'm saying Shakespeare-style sonnet is because, as you can see in the last point, poem generation is a very complex task, and model should be tweaked depending on the poet whose poems you want to generate. So there has been a lot of research focusing on Chinese style poetry and Japanese style poetry, but very little on only on Shakespeare style sonnets. So the model we have generated, it maybe can be extended to other models, but as of now, the focus has been on Shakespeare style sonnets. So in the interest of time, I will move ahead to our implementation. So in the data set, we have considered all 154 sonnets written by Shakespeare. Now, since we are using a character level stacked LSTM model, the number of characters becomes very important. So that is the reason there are a total of 94,602 characters, out of which there are 62 unique characters. And these characters are encoded to numbers between 0 and 61. So now moving ahead to the model architecture of the model itself. As you can see on the right-hand side, this is the model we have used. So the training corpus consists of 94,000 characters, which has been split as X and Y data. Now, the first 50 characters have been split into the X array, and the 51st character has been split into the Y array. And now this has been vectorized and passes input into our model. So basically what we're doing is we train the model by passing a sequence of 50 characters and train it to predict the 51st character. And as you can see, we have used 2 LSTM layers. So we carried out analysis comparison by using 1 LSTM layer and 2 LSTM layer. And we realized that by using 2 LSTM layer, we were able to generate a much better poem based on the overall context of the poem. Further, after the 2 LSTM layers, we have used a dense layer so that we can reduce the number of features from 256 back to 62. And then in the end, we have used a categorical cross entropy loss function to basically get a one-hot encoded vector of length 62, in which 61 values will be 0, and the one value which will have the value 1 is the character generated. And a recurrent dropout layer has been used so the model doesn't overfit the corpus. So the main novelty I would like to talk about here is the stacked character level LSTM. Now, one thing which we thought about here is using a word level LSTM. But the issue in word level LSTM is, first of all, the dataset size itself. There were only 152 sonnets. So in 94,000 characters, using a word level LSTM is not such a good idea. And also one issue which we were facing was the out of vocabulary problem, in which case we were not able to generate original sonnets. Like most of the sonnets were coming as like similar to what Shakespeare already written. So that is the reason we use a character level LSTM. Moving ahead. So this is the model. Now for testing in NLP, there are many automatic evaluation techniques to measure the perplexity of the model. Automation evaluation techniques are such examples are BLUE, negative log likelihood, etc. But none of these automatic evaluation techniques could match the accuracy of actual human evaluation. Hence, we generated a few sonnets and asked human evaluators to rate the poems on the following 4 characteristics, which is fluency, coherence, meaning, and poeticness. So as you can see, this is just an example of 5 sonnets I've given in the slides. So sonnet 4 and 5 are original Shakespearean sonnets, and 1, 2, 3 were generated by the model. So if you see at the overall score, sonnet 3 even beats sonnet 5 as rated by the human in terms of how good the sonnet is. And people weren't really able to distinguish if the sonnet is generated by Shakespeare or by a model. So this gives us our conclusion. Based on the testing metrics, the quality of sonnets generated by the model are very close to the quality of the actual sonnets. And it was very hard for the human evaluators to distinguish the sonnets generated by the model from Shakespeare's works. So yeah, that is the conclusion of our research paper. And as far as future is concerned, I feel that right now there's been a lot of work on poet specific, not on Shakespeare, but poet specific, and topic specific poems can be extended to topic specific poems. And the second is that new genres of writing can be discovered by combining poems not only from the same poet, but from different poets. Yeah, so these are the few references we have used. Thank you.
Fine, seems fine. Okay, so no question. Any question from audience? If it.
Okay, fine. Thank you so much, Ash. Nice presentation.
Thank you.
So next presenter is Riaz Ahmad, and the paper title is the Combining Generative Advisor Networks with the Transfer Learning for the Deep Learning Based Pomegranate Plant Leaf Disease Detection. Yes, I think she is absent.
It's not there, I think.
Yes, sir. So thank you so much for the excellent presentation and this session, and all the participants for being a part of this international conference. I hope this session was informative enough to all. On behalf of the whole team, thank you for the support during this version and the previous 6 versions of the conference. We will be happy to have you in the 8th version in 2024. So all the presenters would be getting their digital certificates through the email within 2 working days. Further, all the paper have already forwarded to the Spincher. The publication will be live within 6 months. So kindly cooperate with the team of ICTCS. I also thank our session chair for chairing the session, Professor Jitendra Bhatia.
Thank you.
Yeah. Here is the token of appreciation from the team of SMARTCOM and the Global Knowledge Research Foundation, sir.
Thank you. Thank you.
For the valuable information to the all authors. And the end of the session, I would like to request you all, please turn on the camera to make a quick snapshot of this virtual conference.
But on behalf of entire group, I would like to thank Jiten sir for his presence and helping us with his knowledge areas so that we can improve on different aspects.
Thank you, Sumita. Thank you.
Yes, thank you so much, sir. And best of luck for the best wishes for the future. Right? So
by when we'll be getting certificates and other set of things?
Within 2 working days.
Okay. That will be on mails itself, we'll be getting it.
Yes, yes, through the mail.
Okay. Thank you, everyone.
Yeah. Thank you.
Thank you.